Hey there, welcome back to the Andromedoom devlogs, episode number 7. If you'd like to skip ahead to the content, please check the timestamps in the description down below. In this episode, I'll be showing you how to implement camera shake for the destructable objects using Godot's built-in tweening engine. And in today's devlog, I'll show you the progress on the main game, which involves a lot of visual changes, but not so much functionality changes because I've spent a lot of time refactoring the code and trying new things. Alright, let's switch over to the screen. Alright, this is where we left off last time. In the last episode, we showed how to implement a finite state machine for the alien AI. Now this time, let's implement camera shake. So I'll attach the camera shake script directly on the camera because the spatial node camera azimuth already controls its movement. But if you need more complex functionality for the camera, then you might want to look at perhaps composition rather than attaching the script directly. And call this camera shake. Now we're going to be using Godot's tweening engine. So we could declare a new tween. And whenever you use a tween, you need to add it as a child. So if you don't do it in the editor, make sure you do it in script. Child tween. Now what we'll do is we'll feed a random position to the camera transform every frame, and we'll use the tween to interpolate the shake method from the initial value back down to 0. So to do this, we got to store the camera's default position. So in the scene, the origin is 0, 0, -4 relative to the camera altitude node. But we'll just get this using the ready function. So default position is equal to transform dot origin. Now let's create our shake method. And into it we'll pass an amount, which is the amplitude of the displacement. Let's make this a field, so we're not initializing a new vector every time the function is called. And here we'll assign offset position a new vector 3. And we'll get a random range, so using static Godot.gd, because the random range function is in the GD singleton object. And range, we'll go for -1 to 1. This function returns a double, so we'll cast it to a float. Do that again for the Y component. And for the Z component, we'll set that to 0. Z is forward and backward. We don't want the camera to move forward and back. We'll just want it to shake in the XY plane. And we'll take this vector and multiply it by the shake amount. That's a position offset from 1 in the XY plane. We multiply it by some amount, some amplitude, and then we add that to the default position. And then we update the transform. Now C# uses value and reference types, so you'd have to create a new transform and then assign it back to the transform property. You can't modify the transform fields directly. So here we'll say private transform, new transform. And so the new transform is equal to the current camera transform. And we update the origin to the offset position. And then we set the transform property on the camera node to new transform. And for clarity, I'll just add this, just so it's clear what the differences are. So this is the shake method. And if you pass in an amount of 0, then this random vector goes back to 0. So it just resets the camera back to the default position. But now how do we call this function? Well, the idea is all of our objects that get destroyed, or that take damage rather, whenever they take damage, they pass a signal to the camera object and call the shake function. So we'll create another method called receive shake. And this time we're taking an amount and also a duration. And then on our tween, which we added to this camera, we use the interpolate method. The object is the first argument. The target object is the camera, so just this. It's the shake method. So we use name of shake. The initial value is the amount that we're passing in. Final value is 0, so the shake will stop, and the duration is the duration we're passing in. Final two parameters are optional, but it's the transition type. So how do we go from the amount back down to 0? Now by default it's linear, which doesn't look that good because there's no smoothing between in and out. So to visualize this, we'll export some fields that you can adjust in the editor. Export enum, so tween dot transition type. We'll call this transition type, and we'll default it to, let's say it's parabolic, so quad. And similarly, ease type, we'll make the easing out, and so we'll start off sharp and then quickly reduce and smooth out the shaking. So here we'll pass the type, and here the ease type, and then we start the tween. That's basically it. Now recall in the earlier videos, the building, the player pad, and the alien are all destructible objects. So they all inherit from the destructible class here. So we'll attach that functionality to this class. To send a signal, we use the signal attribute, and we create a delegate function. And delegate void, and we'll call it send camera shake. And we send an amount. And a duration. Now here's the tricky part. We need to connect any destructible object to the active camera. Now because we're not directly instantiating the destructible class, if we put it in the ready function, and the way we do this, first we store a reference to the camera, so and then we can just get viewport and then get camera and get it as type camera shake. And then we use the connect method. Now the signal that we're connecting is the camera shake signal. Oops. Name of send camera shake. The target object that we're connecting to, the one that receives the signal, is the camera. The target method on the camera is the receive camera shake method. So we'll say name of camera dot receive shake. Now I've connected the signal. So the camera is awaiting the send camera shake signal from every destructible object. However, there's an issue here. Because this destructible class is not directly added to the tree, only its subclasses are added, this ready function is not being called unless we go to every destructible object and we call the base ready method. Alternatively, you can change this on the enter tree method, and this works as well, but the Godot engine documentation advises against this. So we'll keep it on the ready. So just be mindful that everything else that implements from it should call the ready function. Now every time destructible object takes damage, we emit the signal. So use the emit signal method, and the signal is name of send camera shake. Then we pass the parameters, and the parameters are the amount and the duration. So what we can do is pass the amount of damage that we've taken by, but this will create a huge offset. So we'll also export a multiplier. And we'll make it 10% of the amount. And the duration, and we'll default that to 1 second. Alright, let's see if this works. If you hit a building, it shakes. And if you hit the alien, it shakes too. And if the alien fired back and destroyed the player, it will call the same function as well. And so you can, because these are all fields, if you hit build, all the fields will be populated here. And so the camera shake fields here, these are the different types of interpolation methods and the ease methods. For the shake, you'd probably want to use out for the ease, but the transition types you might want to play around with. Similarly, go into the alien, you can update the script variables here. So I should give a more descriptive name for this one. This is the shake multiplier and the shake duration. And one last thing you'd probably want to do is export another field here. Call it shake limit. Maybe make that half, and then you just maximize it using the minimum. So it's the minimum of the amount or the shake limit, whichever smaller. And there you go. Pretty straightforward, simple and sweet. Thank you for watching. Hope you enjoyed that tutorial. If you have any questions, comments, suggestions, please put them in that little box down below, and stick around if you'd like to see the progress on the Andromedoom main game that's coming up. Alright, welcome to the devlog of the main game. Finally, we're in the Godot editor at episode 7. Let's hit play and show you what I'm up to. And this is actually a bit, because I've started from scratch, it's actually a bit less developed than the prototype. And what I've been working on mainly is just trying to get the visual feel for the project. So if we hit play, it'll take us directly to the Sydney level. And so this is the style that I'm going for here. You've got the city buildings acting like the shield, so you got to defend them. And you've got the crab alien landing through using that finite state machine AI that I showed you, which will be more developed in this game, in the main game. And the terrain uses simple pixel art. It looks like a map. So you'd have an ocean layer, and on top of that you'd have like a terrain layer, which is sandy colored in the Asia Pacific region. Then you'd have a foliage layer just for detail, and then an urban layer. Now I'm trying to, in the visual style, also indicate the play area. So there are limits, there are invisible walls on the level that prevent you from going outside it. So I'm thinking of ways to try and hint to the player visually where the level bounds are, because that's where the aliens are going to be landing. Look at that, the alien has landed. I'm not sure how I feel about the pixelated edges on the terrain layers, but although I haven't looked at this yet, but it looks like Godot can handle an SVG import, which would give me crisp, clear lines. So the idea is, and I'll try and work this, is to work with pixelated textures like this, repetitive textures, so it looks like a map, but have the clear lines of vector art defining the shapes of the map layers. And this is inspired by the clean visual style of Revenge of the Titans, which I mentioned in devlog number 0. So you get a feel. One other thing that I did not show is taking damage like Call of Duty. So in Call of Duty, you take damage and the screen fades to grayscale. And if you keep moving, you don't heal, the ship doesn't heal. But if you do, if you take cover and you stop moving, you'll slowly start to heal again. And as you heal, the visual indicator will be the color coming back into the screen. Yeah, so and the way I've done this is with the OpenGL, or Godot's implementation of the OpenGL language. It's a shader attached to a viewport container. Very simple script. And the grayscale that I'm using takes the red channel, so the red objects will be very luminous. I think that's a cool grayscale effect. And we export the intensity property here, so we can adjust that in script. Let me know if you'd like to see a full tutorial on how to adjust shaders in real time. And so I plan on adding extra shader effects that change at runtime. Like for example, the squid would ink the player, so you'd get a blackened screen, and things like breaking glass. Every time you take damage, the ship has a broken glass effect, so it gets more difficult the more damage you take. Yeah, some ideas I'm throwing out there. But next steps at the moment is to first of all figure out how to animate the alien ship, because I did animate a bunch of behaviors in Blender, so getting the animation player working, and then importing everything. So importing all of the aliens and writing up their AI scripts, build up the 6 levels in the Asia Pacific region, and then try and build all of the auxiliary components of the game. The main menu, the saving and loading system, so the profile manager, which keeps track of the player statistics, A lot of the visual styles of the scrollable maps, the level selections, also the shop function, all of that needs to be implemented. So I have fallen behind a lot because of the art, but I am making a lot of ground in the coding and assembly aspects. So maybe I will catch up to the program. The way I've been refactoring the code is to put a big emphasis on scalability, particularly focusing on the finite state machines, getting a good implementation of that, because that saves a ton of work. With the completion of this entire vertical slice thoroughly, adding all of the extra content is just cookie cutter work. So you just create the artwork, code the alien AIs, but the core functionality is the same. So at the moment, what's holding me back is the artwork. Producing artwork takes a lot of time. However, the coding has run a lot more smoothly than I anticipated so far. Knock on wood. All right. Thank you for watching. Hope you took something away from this devlog. If you'd like me to explain anything in further detail, please put it in the little box down below. And if you enjoyed this tutorial and the devlog, please make sure to hit like and subscribe and hit the bell as well so you get notified when the next episode drops. And I'll see you in the next one. Thank you very much, guys.